Alright, so when I hand these out, this first page, make sure you have glued it in your notebook by tomorrow. You're going to see it's going to list every day's lesson out, what the homework will be. Every day we're going to score, right after you grade it, you're going to write your score and say, did you turn it in on time? And we'll have a quick reflection part. Nothing much, just a couple words. Day one, this is where we are at. Our 6th chapter, everything we're going to learn about is scatterplots. So our learning goal is, I can use scatterplots to describe patterns and relationships between two quantities. So open up your pamphlet, your little foldable. Open up the first orange page, and it should look something like this that says, what is a scatterplot? And we're going to fill part of this in together. So the first thing that we are going to put in here says, what is a scatterplot? A scatterplot is a graph that shows the relationship between two sets of data, or between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. Part of your assignment, part of your grade is the note-taking. So when I look tomorrow to see, did you do your assignment? You have to have the notes completed with us and the homework assignment. And I promise you, I'm doing most of the notes with you, and the homework is very small. Remember, after 3 late works, you owe me lunch. So it's not like a threat, it's just I want you guys to really focus on getting your work done. What this says, pretty simple. If you look on that page, that orange one, do you guys see those 4 graphs underneath? And there's dots all over them? Those are 4 examples of scatter plots. We will get into those more tomorrow. But what do you notice different between the scatter plots and the graphs that we just finished last semester? Yeah, so like last semester, when we had our dots, they were all in a straight line, right? And we were able to just draw one straight line and connected all the dots. In real life, the majority of the time, unless we have that constant change, in real life, most things vary. There's not a set rule of exactly if I am this tall that I should weigh this much. Those change. Typically, yeah, we see that. The taller you are, usually you weigh more. But if you're a sissel, you're usually shorter and weigh more. My whole family's all short and little hobbits. So, it doesn't always fit the whole little linear line. So we don't use those. We use something called a scatter plot. And in our definition, we said 2 sets of data. In that last example I said, my data was height and weight. So I'm comparing the height and the weight, and every dot, if you look on there, every single dot was put in a specific place. And it's because of its ordered pair. Where is it on the x-axis and y-axis? Those coordinate points give you an exact location. Okay? Now, all those dots are scattered around, and we'll get into that part later. What I want you to do is turn the page so you're on the pink side that says graphing scatterplots. So go ahead and turn your page. We should now be on the part that says graphing scatterplots. And we're going to work on this. Alright, you should see it says steps to make a scatterplot. That is today's main goal. you should be able to make a scatter plot. That's going to be your goal. There's 3 steps we are going to work on today. We're not going to do the 4th step yet. The 3 steps are we need to determine the scale for the x and y axis on our graph. We have to decide, remember, scale means what numbers. Does it go up by 2s? Does it go up by 5s? Does it go up by 1s? We need to title the graph and label the axis. And then the last one, we use order players to plot the data. So we're going to start on number 1. Because number 1, there's all these mini steps underneath, and they're very easy. So the first thing is, we need to find the range, which is the largest number minus the smallest. So let's scroll down here. You should see on your foldable, it says practice graphing. Use the table to make the scatter plot. Here's our table. Scatter plot is between 2 sets of data. What data are we using? What are we comparing right now? Absences and final grade. Good job, Zachary. Above absences, I'm going to put X. That is my X coordinate. To be honest, can you mix them around? Yeah, but typically when you have a table, that first one's going to be your X, which means the Y is my final grade. Now, if I look back at the first instructions, find the range of my X values. What is the largest number? 10. What's my smallest?
0.
So my range is between 0 and 10. How many lines do I have on this x-axis? If we count, I have 1, 2,
12.
we have 12. Do I need to divide and break this up, or can I go by ones? We can go by ones. Make sure you understand this. On our graph, when we do these scatter plots, the first corner, that's your origin. That's always going to be 0. Okay. Since our biggest number is 10, and I have 12 spots, that's easy. I'm going to make all of these go by ones. So, go ahead and number these. Okay, so I did 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll give you guys a couple seconds to make sure we're caught up. If I look at my instructions, okay. So I need to repeat the same thing for the y-axis. So I'm going to do this now. Let's look at our y-axis, because now we have to work with it. What's my largest value on my y terms? 95. Let's put an H over here. We'll just say this is our high number. What's my lowest number?
70.
Sierra? Nope, there's one. There you go. Good job. 65. So here's what we're going to do to find what my scale should be on my y-axis. Underneath, I'm going to show my work here. I'm going to say 95 minus 65, which equals 30, right? My range is 30. If you ever have to find the range of any set of data, it's just the biggest number minus the smallest. So my range is 30. I then take that range, and I'm going to divide it by how many lines do we have available? We still have 12, because this is a 12 by 12 grid. So we need to do 30 divided by 12. Ooh, I like how'd you know it was like 2? Who was it? Is that you?
It's almost 15, and 15 is half 30.
Good, that's good estimation. We know it's about 2. It's not 3, because 3 would be too many, but I'm going to use this and say 2.5. Now, here's something important. I don't think we have this part written down, but I need you to understand it. Okay, good. We don't. Okay. My scale does not have to be 2.5. Okay? This is just telling me about where it should be. I can take that 2.5 and I can either use it or I can round it up if there's an easier number. Me personally, I don't mind 2.5. Counting by 2.5 isn't hard. but we might not like it, and that's okay. If we rounded it up, what do you think we should round to? Probably 3. Let's go ahead and do that. But here's a change. If I'm not going to start at the very first, we would have to do a big squiggly line. If I look at this, and I'm going to show you why. On my y, do I want to go 0, 3? What's my smallest score? 65. So stay with me on this. That very first line right here should be 65. But if I was to look at your graph and I see 0, 65, what's that tell me you're skip counting by? 65. Is that what we said we were going to skip count by? No. So this is important because I know you will see this on test. You put this little guy in between that very first one. It's a little squiggly line. That tells anyone reading the graph that there's missing data between here and there. Between 0 and 65, we just condense. It's almost like you took it, you squished it down, and it's kind of squeezed down and compressed. It's saying, hey, we don't have any information there. So instead of starting at 0 and having a whole big blank, we're going to start at 65. Now I can use my scale of 3. I personally don't like writing on every single line. I think that gets too many numbers. If you like it, that's your choice. So you can go 65, and next number would be 68. If you want to write 68 there, that's fine. Me personally, this is just my preference. This is not a right or wrong answer. I like skipping lines. So I would do 65, 68. This would be 71, 74, 77, 80, 83, 86, 89, 92, 95, 98 is my top. So I still use the same scale. It's just me personally, I don't like writing a number every single one. I think my numbers get too cluttered. I'm going to put it in anyways with the other color, and I'll show you. But you could have done this. This is okay. But everyone should end up with the exact same thing right here. Parker, are you with me on this? Parker, sure thing.
Or wire.
So you can be doing this with us. Alright. So if you're seeing this, we decided right here that our scale had to be at a minimum 2.5. We made it 3, just because that was an easier number to count by. That became our scale going on our y-axis. We did the squiggly. Why did I do the squiggly? Ryan?
Because it's like compressed.
Good, it's compressed. We didn't follow the scale to start the very first one. And started going 0, 3, 6, 9, 12, 15. We would have had a whole empty space. We would have had to make a really big graph for no information. So this squiggly shows us that there's missing data. If you have a big jump from 0 to your smallest data point, insert squiggly line from 0 to first line on axis and label with your smallest data point. Okay. Continue to label your x-axis counted by the number. Well, we're doing our y-axis. We found that we are making it 3. That was our scale. These all go up by 3. Last thing we have to do, title the graph and label the axis. Or the last thing we're going to do today. Title the graph and label the axis. What do you think our title should be? What should we title the graph? This is really important. People lose points every single time because they don't do this. What do you think we should make our graph title? What's this? All this information going to be about?
Absences. Final grades.
Final grades. We can make it final grades. We could do abscesses versus final grades. I'm just gonna write final agreements. The important thing is a title tells the reader what your graph is about. You must always have that title. It then said, label the axes. These are something we forget every single time. What is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? What are those about? What are those numbers representing? The absences. So underneath, we label that. So we put a label under that axis. This axis is about how many absences you have. The y-axis would be what? Yeah, final grade. Alright. The last step that we will do is use ordered pairs to plot the data. What I want you to do for your assignment is you need to plot these points onto here. That's your homework assignment. If I do the first one, I'll even help do this with you in red. Absence, 0, final grade 95. So I go 0, 95, there's my dot. One hint for you, what I do, once I'm done with one, I put like a little mark in there. The next one was 3 and 88. Okay, 3. Does it show 88 exactly? No, there's 86, 89, so 88's. And here's the best part. Scatterplots will not be exact. You might have it off just a little. That's going to be okay with what we're doing. So I've done that one. I need 2 and 90. 2 and 90. Somewhere there. 5 and 83. Alright, I have now done 4 of yours. You need to do the next 1, 2, 3, 4, 5, 6. Your assignment for tomorrow is just finish those 6 points. Tomorrow when we come to class, we're going to do 3 of them together. That was supposed to be your homework tonight. Instead, I'll let you work with a partner tomorrow in class, then we'll finish that up. Any questions? T? Sure.